So anyways, I'm Jason Howe. This is our agenda for today's presentation. I'm gonna give a little introduction. I have actual pictures this time. We'll talk about what systemd is, and then I'm gonna show you how to use it for malicious and sinister things. So yeah, here's me. I red team. I do Linux research. By that I mean I read man pages to figure out how to use and abuse default functionality. So everything that I'm gonna put out today is like built in to systemd that you can just do and use it for malicious things. So I enjoy my shells. Yeah, up here I'm gonna want to picture me and Malik. It's a picture of me carrying Alex Noble out of the Cyber Range conference room. I don't think he's here anymore. That's unfortunate. That was a fun time. Yeah. Anyways, moving on. So background systemd. Systemd is an open source tool. It's it's the init system for lots of Linux distributions now. So when you start up your operating system after execution gets passed from like your bootloader to the kernel, this systemd is process number 1. It handles pretty much everything. It does it very well. And there's actually like a lot of lore about how they did this. So it's a lots of good documentation, good read about it, lots of blog posts. But yeah, it handles all the core services for Linux specifically. So all your networking stuff, all your logging stuff, all of your other things. Yeah, there's a lot about low-level system architecture stuff that you could talk about here that I'm not totally in the know about, so I don't want to spread this information. But it is also compatible with 2 other init systems. One is RC, which is used on BSD, and the other one is sysb init, which was more or less the predecessor for systemd. Is what was used in a lot of Linux distributions beforehand, and had a lot of issues that were just like architectural issues that kind of got solved with systemd. So yeah, it was released in 2010, widely adopted by 2015 across all common Linux distributions. So Debian, Ubuntu, CentOS, RHEL, Rocky, I guess is what that is now, Arch, all use systemd. So yeah, it integrates system and service management on Linux systems. So it really focuses on parallelizing the boot process, and it does that by interconnecting everything in a thing known as the Debus. So basically, think of Debus as a giant like trough, and you just like throw stuff in the trough, and then stuff that needs stuff gets it out of the trough, and you use it that way. And by doing this, there's no more like process interdependencies. So if you guys know anything about how Linux boots up, like you have to like load up something A and then something B and something A first. You have to wait for A before you get to B, but something C needs A and B. It has to wait for both of those. So it just kind of creates a lot of dependency issues. The trough, known as Debus, kind of solves those issues just by throwing stuff in the trough. You pick it up when you need it. Anyways, systemd tools. So all of these things on Linux are provided by systemd. sysctl lets you set kernel settings. Systemctl is your service management. You can set your host name. You can do login management. Journalctl is log messages on Linux. Resolve network is DNS networking. So yeah, a lot of like these core tools that people use for system management on Linux are all provided by systemd. I don't know if all of this was part of systemd, which is really cool. So a fun thing that I learned that I'm not including in here, but in the sleep.config file, you can configure actions to take when buttons are pressed on systems. So there's a setting for like a long press on the power button, and you can change that to ignore it. So if somebody tries to like reboot a system by pressing the power button for forever, you said ignore, it's not gonna do anything, which is kind of funny and goofy. But yeah, that was something I learned reading these man pages. Anyways, so yeah, systemd services is what we're really going to be talking about, the meat and the bones of how we use this maliciously. So services are background processes and daemons that run in the background. So if you're on the terminal and you write like cat this file, that's like a foreground process because you can see the output of what's happening right in front of you. If you use vim, that's like a foreground process. If you run docker compose up, but you forget to use the tac d flag at the end, you're going to start your container in the foreground, which is cool if you want to do some debugging, but not cool if you want to have it in the background while you do other things. So, yeah, it's a systemd services are a way to background processes. There's other ways you can do that using like double ampersands. And yeah. So yeah, there's a couple of different ways that you can set up a systemd service. There you can set them up through a package manager like apt or DNF. They can be set up by system manager, or they just be present on the system by default. So fun tip on this one, all of like the system, like all the user created services are going to be in etc system systemd, like that directory. All the ones managed by package manager will be in lib system systemd. So if you want to know like what's installed and what's maybe malicious, check that. Some examples of some systemd services: you have SSH, MySQL, Docker. Pretty much anything that you can set up as a scored service in competition is generally provided by some sort of systemd service on Linux. So types of systemd units. So everybody's familiar with services. They also have a lot of other cool, fun ones. Like a device is a device represented by the kernel. It could be like a mouse, could be a keyboard, some other peripheral. You can have a target, which is just a group of systemd units, and this is kind of how you specify that you need to wait for some target, so like the network target, the kernel target, stuff like that. You have timer files, which is a way you can have scheduled tasks. Instead of using cron, you can use timer files in systemd. You can also do like mount and like manage directories and mount points on the kernel that way. So not the kernel, just on the file system. You also have paths, but there's links to actual files. And then sockets is the other cool one, and I mistyped that, but yeah, it's an inter-process communication tool, which you can use, and I'll show you later, for malicious things. So yeah, and the way that systemd detects all these things is the first, like the name of it up here, and the dot mount, dot socket, dot service, whatever, like that specifies what kind of systemd unit it is, and they're all connected by having the same name. So as we'll see later, you can connect a service with a socket, and you can use that to get a shell. So when you do that, you name them the same thing, but one of them's a dot service, the other one's a dot socket, and you just follow on from there. So those kind of connected by names. So yeah, this is an example of a normal systemd service file. This is one for SSH. Here's a better picture of it. So like big things to note here is like the unit section kind of gives us a bit of like some metadata about the systemd unit we have. Give us like a name, a description, tells us what we're waiting for. So remember how we talked about like dependencies. We're going to start this systemd service after this is ready and after that is ready. Then the service is just the configuration options for the actual service that we have here. So you can say that we have like the install is like other things that we're kind of waiting for. These three sections are the ones that you need in all of your unit files. So yeah, as I said, yeah, does this make sense? I mean, not make anybody confused. Great. So yeah, doing this maliciously, which is what you all came here for. So, in an example, the ways that we can, like a very basic service file is a way that you can have persistence on a box. The way you do this is you would create a service, you would tell the exec start, which is the command that you need it to run, just to be like the path to your binary, and then assuming that it's some sort of beacon that will call out once, and just stop instead of like running forever. You set it to restart, and you can tell it to restart every 120 seconds. So that look a little bit something like this. So assuming that banana is a malicious binary here that gives us some sort of beacon, we're just gonna call our binary here, restart it all the time, and restart every 120 seconds. So this is a service file that you would drop in etc system systemd, and you just enable it, start it, you're good to go. Yeah. So if you ever want to make a very simple, like persistent service on Linux, here's how you do it. So abusing some of the built-in service options to do some fun stuff. If you noticed over here in SSH, we have this little thing called exec start pre. This is a command that gets run before it starts the service. So this means that every time the service gets started, we're going to run this command, and we're going to start it, and that's that. So in a normal situation, there's probably not much you need to do before you start a service. But if we append something to the service file, and it says exec start pre my malware, now every time the service gets started, we're going to run our malware, which is really cool. You can do the same thing with the exec start post, which happens after things have executed, which gets ran after things get successfully executed. And then there's another one, exec stop post, which gives you the same options here. Note on these commands need to run successfully and exit. If they don't, and they're hanging, if it's some sort of process that's going to loop for forever, you'll never actually finish executing. And after a while, so you'll time it out and be like, there's an error here. That's not cool. You can use like a dash character to specify things that might fail or might take forever to run. If you have some sort of command that does fail, it'll stop the execution if it's in the exec start pre. It'll prevent the service from actually executing, which isn't cool. And then the other way that we can maliciously use these things is like the command that is executed in any of these any of these settings. It can be whatever we want it to be. So we could do our malware and like the binary, or we could do like create a user and run the binary, or delete this file and run the binary. So we just kind of like chain commands here and run them. And every time the service gets started, gets ran, gets stopped, we're executing our malware, which is pretty nifty. So talking about other options, we have timer files. We can use these as a way to run scheduled tasks. So this is an example of a very simple one where we have our timer file, banana timer. Every 5 minutes, it's going to run. It'll start our banana service, which, looking back on it earlier, is just running our banana binary. Pretty simple. Any questions? All right, cool. The other cool one is the sockets. So in our sockets file, we specify the port, protocol, and then what service we're going to pass it to. So in this one, we're just listening on port 444, and then after we get our connection, we just pass it to our service file. Here, we're starting bin bash, and we're passing all the input and output into the socket. So if this was running on your system, you could connect to the port using netcat, telnet, whatever it is, and then just get a shell, which is pretty nifty. Yes. I don't know. I don't think so, but possibly, since sockets in general are just like there's just wraparound IPC, so it's possible. I don't think it's designed to be used that way. I think all the arguments are for like what you're listening for, but yeah. A normal usage of this is like you would create a socket for like listen for logs if you were like a logging server, and then other programs could write information into that socket, and then it would all just be like localhost communications. So that's kind of what they're supposed to be used for. Anyways, it's how you can use socket file together shell. And then the coolest one that I learned in making this presentation was how you do some prives with a system CTL. So say, as an operator, you have an unprivileged shell on a box, and you need to get a root shell, because root is always better than not root. So anybody know what kind of permissions you need to have to write to etc system systemd? Yes, it is root. So if you're not root, that's kind of an issue. So, but what we can do is use a location that is writable by everybody / whatever you have access to write to. A good example of this is /temp. Everybody on Linux can write to temp. Very fun that way. So you can just make your service file in /temp. Then you can use the systemctl link command, and this will automatically make a symlink between your service file and a place in systemd. And then you just start your service, and then all system services are ran by root. So in here, our exec start command is just a reverse shell callback to, that's kind of your favorite, but so reverse shell callback to our C2 server or our operator IP address, and then boom, you get a root shell. So that was pretty cool to learn about. Yeah, there's some other fun stuff that I learned in reading these man pages that I'm not going to share, because they will be used in red team engagements in the future. I'll describe what it was, but not not the specifics. There's a way that you can set setting to make like a service look like it's alive, even if you kill all the processes, which is pretty cool. So as a red teamer, we like to, if we kill the processes like that are like the SSH server are using to run, but the service itself says that it's running, a blue teamer is gonna be like, huh, service is up, I'm good, my score is down, I don't know where to look. So that was kind of fun. Any questions? Yes.
Do you not need elevated permission to run systemctl link?
No, you do not. Yeah. So this is an example of a GTFO bin. There's lots of like cool living off the land techniques over there. So yeah. Other questions? All right. Thank you all for coming to my educational talk about Sinister systemd.